Now, once our application database is created, what comes next? What should we take into consideration? Do we have plans for any database failure? Do we have any contingency set up in case our database shuts down? In 1, 2, 3 years from now, how many users have access to our application? Do we ensure same performance and availability of data in the future? Hi, I'm Daisy De Castro. As a continuation of our physical database design, I will be discussing about the concept of a distributed database technology and design consideration. So let's get started. What is a distributed database system? Here is an example of a centralized database system which only have one database shared across different sites. A distributed database system, however, may have one or more databases allocated in each site. By definition, it's a logically interconnected set of shared data physically scattered over a computer network. It's characterized by a collection of logically related shared data. Number of data is split into a number of fragments. Fragments may be replicated. Fragments or replicas are allocated to sites. The sites are linked by a communication network. The data at each site is under the control of a database management system. The database management system at each site can handle local application autonomously. Each database management system participates in at least one global application. There are techniques in distributing data across network: extraction, segmentation, and replication. The most common technique used is the replication, which is mostly available as built-in feature in almost all database server management tools. We will focus on data replication in succeeding sections, but let's first define extraction and segmentation. Extraction. This is the method of extracting data from the source and load the copy to another system. Usually, developers will develop a program to copy data and save it to a flat file or a separate disk for further processing. Next is segmentation. This is the physical partitioning of a database into a set of separate physical database tables, which then can be stored at different sites. The database tables are not duplicated, but only implemented at different sites. This method will distribute data across cluster of nodes for fast data purging and increased query performance. And then database replication, which allows the automatic generation of several copies of either full or partial database table. The benefits of having a data replication are the following: improved performance and data availability. Since each remote site have a copy of the data, each site can handle user requests autonomously and more efficiently. We can also use the replicated data for disaster recovery. In case of any site failure or database failure, even the main database source, we are ensured that the data can be recovered from another site. More than just copying, replication can be used in ETL processes. We can filter, transform the data, and load it in another database suitable to business needs. There are two common terms or parts used in data replication. First is the master or the publisher, which is the principal database that distributes the data to other databases. Next is the slave or the subscriber, which are database instances that receives the replicated data. Now, let's proceed with the types of replication. The first one is the synchronous replication, which is also known as the real-time replication. It ensures that all data are always up to date and in sync at all locations. There are two common phases in a synchronous database. First, changing the data and then committing the changes. All of these operations are simultaneously executed in a synchronous database. Hence, any error in executing any changes will stop any replication from executing in other databases. It also ensures that all databases will have the same data at any given time. Second one is the asynchronous replication. Data are copied to each database singly and out of sync with each other. In asynchronous replication, the lag time of transmitting replica to each remote database must be acceptable with the business. The database updates are stored in a deferred queue and will be transmitted at scheduled time. It should ensure that the data are replicated to each remote location successfully. There are propagation timing mechanism that is used in asynchronous replication, which you may consider depending on your requirements. The first one is the time interval scheme. If your application requires a real-time data, the time interval for replication must be within few seconds. Otherwise, you can set it up in minutes, hours, days, or even week. Next is the event-based scheme, which for any changes in data, the mechanism will trigger replication in each databases. Last is the on-demand scheme, which is initiated by the administrator. Okay. Knowing the differences of both types of replication, let's summarize each types with their pros and cons. Asynchronous replication will provide a higher availability of data across application. At the same time, limits or avoid data loss and collision. As mentioned earlier, synchronous replication will simultaneously copy data in each databases. Any error encountered may stop or perform changes in all databases. However, since it has to wait for replication to complete, there is an application latency. At the same time, a huge network bandwidth is needed in transmitting copies, especially if you are doing full replication. Hence, it is usually not used in transmitting data in long distances. Asynchronous replication resolves application latency since replication is not happening in all locations. It also requires less network bandwidth compared to synchronous, but sacrifices replication latency since data may be out of sync at some time. It also prone in data collision, especially if you are updating thousands of rows and replication starts again on the same data. Distributed database system poses challenges since we are managing a lot of databases. Changes on multiple locations may arise with some conflicts. Hence, conflict resolution strategies should be taken into consideration in designing this system. These conflicts usually occur for a multiple master setup. A master slave setup usually scales only read operation than write operation. A multi-master setup increases write scalability, however, requires conflict management strategies. Let's first look at types of conflicts that may occur in a distributed database. The first one is an update conflict, which occurs when the replication of an update to a row conflicts with another update to a same row. Update conflicts can happen when two transactions originating from different sites update their same row at nearly the same time. Next is the uniqueness conflict, which occurs when the replication of a row attempts to violate entity integrity, such as a primary key or unique constraint. This happens when two transactions came from different sites insert a new row from a certain table replica with the same primary key. Last is a delete conflict, which occurs when two transactions originate from different sites, with one transaction deleting a row and another transaction updating or deleting the same row. In this case, the row does not exist to either updated or deleted. Server management tools have available resolution to detect and resolve conflicts. The first one is a priority groups, which enables you to assign a priority level to each possible value of a particular column. Next is a site priority, which enables you to assign a priority level to each location. Both of site or group priority can be useful if one site is considered to be more likely to have the most accurate information. Next, we can resolve conflicts through timestamp. First one is the latest timestamp, which resolve a conflict based on the most recent update, or earliest timestamp, which resolve a conflict based on the earliest or oldest update. If you use either of these methods, you must be conscious how the time is computed, such as if it is considering time zones. Then, you may either resolve your conflict by overwriting or disregarding. Overwrite means replacing the current value at the destination site with the new value from the originating site. To disregard is disregarding the row from the originating site that caused the error. There are two options in data replication. The first one is full data refresh, where the entire content of the master database is replicated to other side. Next is the partial data refresh, which only the rows that have changes in master database is replicated to other side. The factors to consider for refresh date strategies are the following: size of the database, volume and frequency of data replication, network bandwidth capacity, tables to maintain, and how to ensure that they are all in sync. Having everything in mind, let's sum up the design consideration we need to ask ourselves when designing a distributed database. First one, what are the data that needs to be replicated? Next, what mechanism to perform? Is it asynchronous or asynchronous? Does it need full refresh or partial refresh? How often the data will be replicated? Are resources available and can meet replication requirements such as network bandwidth, memory storage of each databases in each location? What are failure and conflict strategies to consider and apply? And this concludes our report on physical database design.